This is 15.1. We are defining and evaluating a logarithmic function. Generally, we just call that a log function. And we're not really going to do much on this first page. However, I'm going to add information here so that we understand what a logarithm actually is. Where did it come from? Why do I need it? So if we have this problem written down, we just finished the unit on solving an exponent, an exponential function per se, or a radical. So this would be the inverse of the exponent. For this particular problem, the only thing that's being raised to the fifth power is x. So x is the base, so I need to isolate it. So I'm going to divide by 100 to both sides. And the zeros cancel out, so we've got 96. So now, what we learned in the last unit, to get rid of any exponent, I will take the root. So in this case, I'm going to take the fifth root on both sides. So I'm going to have x is about, it's going to be a decimal. And when I do this in my calculator, don't forget, you go to math, and we want number 5 here, so that we can put a fifth root in, and we're taking it of 96. So x is about 2.5. I could round. That 4 can become a 5 due to the 9. Now, I want to check this. And so we're going to say 100 times 2.5, that's what we got x to be, raised to the fifth power. And notice it is larger than the 9600, but that's because we rounded this number. If I had done 100 times 2.49, you're going to be closer. You're not going to be exact because I cut the decimal off, but notice we're closer. We're under this time because I cut it off. So if I round up, I'm going to be a little larger. If I round down and cut it off, I'm going to be a little bit smaller. I'm still close to the ballpark. This whole decimal is actually what is necessary to get the 9600. So we've worked on that. However, we're going to be working on a problem like this now. This is what we're transitioning into. The same is true. They both equal 9600. They still both are multiplied by 100. However, the base was x, and the base is now 5. The exponent was 5, and now the exponent is x. These two have flipped places. Yet, the first step is still the same. I'm going to divide by 100, so I get 5 to the x. Again, I'm going to get 96. But now, there's no x root. Yes, when you go to math, there's the x root right there. But it's not really an x. When you hit enter, it asks for what root, and we don't know. We don't know what root to take because we don't know what the exponent is. So someone along the way invented this nice rule for us. So log is an operation, okay, just like adding or subtracting or multiplying and dividing. Those are math operations. So log is an operation that isolates, and isolates means to be alone. It isolates an unknown, that's the point of using it, exponent. If you know your exponent, you can still use a log, but we usually use logs when we don't know the exponent. Like here, we don't know the exponent, so a log is going to come in handy in just a second. The other thing that you need to know that's really, really important is a log form is the inverse. Remember, inverse is opposite of exponential form. Okay, so log form is going to be the inverse of this form. Now, we're going to come back to this problem in a second, but I want you to go to page 822, just down here at the bottom. This is where we're going to spend some time writing some information. This is just something to remember, that inverse, so you know this, of adding, you know is subtracting. Multiplying would be dividing. So if you have any kind of root, square root, cube root, fourth root, whatever root, you're going to have an exponent. So you're going to do squared or cubed or to the fourth power. And now we're going to add to this list, if you have a log, the inverse is exponential. And it works the other way. The inverse of exponential is log. The inverse of subtracting is adding. So these are all inverse operations mathematically. Add, subtract, multiply, divide, taking a root, taking an exponent, taking a log, putting in an exponential. Okay, that's really important. Now, right here, this is exponential form. It is the inverse of logarithmic form. Okay, we just call it log. Notice we just called it log. B right here is your base, and x is your exponent, and a is just the answer. Okay, so how does that translate over here? Well, logs also have a base. It's a little bitty number. This time we used a letter, but it's a little bitty called subscript. Superscript is up above, subscript is down below. And so b is still the base. So from over here, the base was b. It's still the base. Now, what I want to remind you of is the goal of a log is to isolate an exponent, usually unknown. The exponent here is x. We have isolated it. This is your exponent. It's isolated. That's important. That's what a log does. So when I go from exponential, I'm isolating the unknown exponent. And then your answer just sits here. I'm going to tell you how to read this in a second. But right now it's a bunch of letters and variables that are not making sense. So we're going to write an example down here. 2 to the 5th power equals 32. Now the reason I'm writing that like that, there's nothing unknown. You can type this in your calculator. 2 to the 5th power is 32. But to rewrite it, I'm going to write the word log. The base is 2, so log base. So I would say log base 2 of, and then I would say equals. Now remember, the goal of a log is to isolate the exponent. The exponent is isolated. So my exponent is 5, so I'm going to isolate the exponent. That leaves your answer, the only thing left to sit here. Important. This little number right here is your base. It should be little. Everything else should be normal size written together. Now I can also type this in my calculator. I'm going to prove to you that it works. So, let's see. We're going to go to math, and you're going to scroll up. You see that log base right there? I'm going to hit enter. And it allows me to put in a log base, so I'm going to put 2, because that's what's on the paper, log base 2, and I'm doing it of 32. And notice the answer is 5. So the log is a mathematical operation. It works. Okay, again, the base stays the base. The exponent gets isolated. So the answer just gets dropped in where there's left. So back on the front page, what's going to help me here is I'm going to say log base is 5, so it stays the base. Exponent gets isolated. And I drop the answer in. Base stays the base, isolate the exponent, put your answer in. Now this is important because now x is alone. If I type this in my calculator, I will have an answer of what x is. So let's type in math up. I want the letter A, base of 5 of 96. X is about 2.8. Again, the more the decimal you use, the better off you are. So I'm going to do 100 times 5 raised to 2.8. But notice I'm well under 9600 because I cut that decimal off so soon. So if I do 5 raised to 2.8359, notice I'm just taking most of that decimal. See, I'm getting closer to 9600 just from using the decimal. So the more of the decimal I use, the more correct I'm going to be. Okay. So we're going to go practice just the rewrite right now. Just the rewrite. So at the top of page 823, you will find this first example, page 823. Now, they gave me exponential form, so I'm going to put it in logarithm form. The first job is to write log. The base here is 4, so that's going to be my log base. The job of a logarithm is to isolate the exponent. The exponent is 3, so we've isolated it. That leaves 64 to be in here. So that would be log base 4 of 64 is 3. I'm going to drop down here and do this next one, and then I'll go back and go the other way. So we're going to say log base 2/3, sorry, not 3, of something. We're going to isolate the exponent, so p is going to be over here, it's the exponent, q. So log base 2/3 of q is p. It's weird because there's all those variables, but that's how it's read. I'm going to work backwards. The log base is 5, so that means the exponential base is 5. Isolate the exponent, so this is your exponent, and it's going to equal 1 over 25. Now if you check that in your calculator, you're going to see that that's true. 5 raised to the negative 2. So hit math, enter, enter, and you get 1 over 25. Okay, so what they did was they squared 2. 5 squared is 25. Sorry, they squared 5. So 5 squared is 25. Negative means to flip. So 25 goes in the denominator instead of the numerator. You're going to have to know that because you're going to be solving these as well. Here, the base is 1/2. Base stays the base. Exponent is isolated. So it's going to equal m. So 1/2 to the n is m. If you notice at the bottom of this page, they were kind enough to fill the table in for you. There's all the answers. But we just practice to make sure we know. So turn to page 824, the very next page. We're going to go through a few examples here. So number 1, you're going to do log. Base stays the base, so 3. Isolate the exponent. So I've got 243. I didn't leave. So log base 3 of 243 is 5. Comes down here, we're going to say log base 3/4. Isolate your exponent, so that's going to be r. So s sits here. Again, this is about rewriting. They're not concerned with you actually doing the math yet. That's why they're throwing in so many letters. Back up here, the log base would be 4. I'm raising it to a negative 3 because the exponent is isolated. So it's going to equal 1 over 64. Again, put this in your calculator. If you just do 4 raised to the 3rd power, and the negative exponent tells you to flip it. So that's going to be 1 over 64 instead of just the 64. Okay, here my base is 1/5. Exponent that I'm going to raise to was isolated, so it's the w. It's going to equal v. Okay, rewriting, rewriting, rewriting. At the very bottom of this, page 824, we have more examples. I'm going to work from the bottom up, and there's a reason. I'll explain it to you in just a second. Log base is 1/3, so I'm going to have the base of 1/3. Exponent is isolated, so this is going to be my answer. To go the other way, the base is 2/5, so that's going to be my log base, 2/5. The exponent gets isolated, and I'm going to have d there. Okay, on this problem, the log base is 2, so my exponential base is also 2. Exponent was isolated, and we're going to raise it to the it's going to equal 1/16. If you type in 2 raised to the 4th power, that is 16. A negative exponent says flip it over, so that's 1 over 16. Alright, the last example. Your base is 10. You're isolating the exponent. Now, why did I not write a 10? This is important. When you write a square root, I don't put a 2 because you know that's a square root. When I write an x, I don't put a 1, but you know there's a 1 there. Log means base 10. So when you look at your graphing calculator, do you see that there is a log button here? When you push it on the screen, you see just log, because that is understood to be in base 10. Always. So if you see the word log, its base is 10. They're not going to write it. So the reason I didn't write the 10 here is because 10 is understood as a base. So I just write it like this. Now what we did was practice just writing this, and actually we played a fun game of spoons. But we did page 823, numbers 5 through 12. We just practiced rewriting. So this is the first part of 15.1. I would practice rewriting.